Hello and welcome to the lecture on understanding the solid principles. So SOLID is an acronym for the first 5 object-oriented design principles, which was proposed by Robert C. Martin. And Robert is popularly also known as Uncle Bob. So if you are reading on design principles of OOPs, then you will come across with this solid principle which was advised by Robert. And he's also known as Uncle Bob. So I've given reference to his website, and all these principles are basically discussed in detail in his article. Okay, so you can go through that URL and basically read more about this principle. The first thing you have to understand is why we need these principles. Well, when these principles combine together, it actually help you to develop software to easily maintain and extend it. Okay, the main purpose of is to refactor the code, also a part of the agile development or adaptive software development, which means when you write a code, it can be extended easily and other programmers can also use it as a library and also extend it further for enhancements of the project. Okay, so this is just a simple welcome to solid principles. I'll give you very high level definitions of what are these principles, but you can, and also I'll leave you with the link so you can go ahead and do your intense study on how the article was published by Robert C. Martin. Okay, so let's understand what are these solid principles. So the first principle is single responsibility principle. So this is the first principle, which is called as single responsibility principle. It starts with S. So it starts with S, and here is the principle. The principle says one class, one responsibility. What it actually means is when you're trying to write a class, your class should think about one responsibility. That class must do only one job. Okay, so that's basically the idea or basically the principle that you have to follow when you define a class. Okay, so here's more explanation about what is single responsibility principle. A class should define a single purpose, and all the properties and the method should work on that single purpose. Okay, you should not jam in two different concepts into one class. Okay, always remember the single responsibility principle and make sure you do one job in one class. Any new changes to the class is only to enhance its feature, not depending on the other dependency. You should not put code because some other child classes want to enhance it and you are missing that feature. You should not write a class depending on your child classes. You should write class depending on its responsibility. That's when the concept of thinking in OOPs comes in picture. When you think about object organizers in classes, you should think about one responsibility. Okay, so here onwards, when you're defining a class, think about this principle. Think about how my class can do one responsibility. If you're writing about student, just write about student. Don't club in the college details in it, university details in it, the examination details into it. Just think about a student. So one class, one responsibility. Okay, when you define about university, think about university. Forget about teachers, lectures, course curriculum, all those things you have to define in another classes. Think about one class, one responsibility. So that's what this principle talk about. When you have this kind of mindset when developing your programs, then it's basically easy to extend and also use by other programs as well. Okay, so this is one of the principles called single responsibility principle. Let's look at the next principle. Hello and welcome to the lecture. Let's look at the second principle. The second principle called as open and closed principle. Okay, this principle talks about open for extension and close for modification. This is how you should think about when you're writing a class. Well, this principle talks about when you define a class and when you have finished putting all those properties and methods for this class, and let's say you have a child class extending it, and suddenly you find out that this child class actually needs some more details which you cannot fit in the child class. Okay, then you should not think about putting that extra code in the parent. You should not do retrofitting of that additional logic into the parent. When you have defined your class with one responsibility, it should be open for extension. Means if there are new features in the same class, let's say you're defining an aeroplane, and then aeroplane basically have extension of the features like engine is changed, it has better flying altitudes, and all those things basically are enhanced in the class, right? It is open for extension, but it should be closed for modification. This modifications basically coming up from the child classes who is trying to modify the existing parent. Apply this principle and say the class is open for extension of that one responsibility, but it should not care about what is the child classes trying to put that modification in the parent. So you should start thinking in open closed principle, and you should also apply this in your programming style as well. Okay, so it should be open for extension and closed for modification. So let's look at some of the definitions of it. A class should always be extended, rather it should be modified. That's what this principle is talking about. A child class's changes should not affect the parent class to change it. The child classes should find a way to create another class maybe, but you should not push those changes of retrofit into the parent, okay, unless that requirement is really an extension of the parent. Okay, the child classes should extend parent and adjust the changes without modifying the parent. So this is the concept you have to remember when you design. This is one of the best practice that you follow for your class, which should be open for extension and closed for modifications. Okay, so that's all for this lecture on open closed principle. Let's look at the next principle. Here is the third principle, Liskov substitution principle. Okay, and this talks about function that use pointers. Pointers means passing by reference, and functions, those are using parameters as pointers, which means a function argument is using a reference, okay, to a base class, must be able to use the object of derived classes without knowing it. Don't get confused with the definition, but try to understand what this principle is talking about. Okay, so here is an example. Let's say you have a method called drawShape, okay, and you are passing a shape. Okay, now this method don't have to remember what shape it is. So this is a method which is trying to draw a shape, okay, and it should not be able to differentiate between what shape it is, okay, because it's a shape, it should just able to draw it. Okay, and you have to write your program in such a way that you don't have to keep checking what is this in your program, right? That is a bad programming style. Okay, this principle says the draw shape should not worry about square or circle. The draw shape, just draw the shape. Okay, that's the purpose of this method. You are writing a method to draw a shape. Now you don't have to worry about whether that shape is a square or a circle, because if you start worrying about, oh, is it a square or a circle, tomorrow when the rectangle comes in, again you have to change your method. So you have to write in a method such a way that you should not worry about the derived classes. That's what the principle talks about. Let's read the principle definition to understand what this principle says. Function that uses pointers to the base class, which is nothing but the shape class, must be able to use the object, must be able to draw shapes of its derived classes, let's say square, circle or whatever, without knowing it. Now draw shape is drawing a shape. So the method that is inside the square or the circle should actually accept the shape and then change it in the child classes, not in the draw shape class. Okay, the draw shape method should not worry about is it a square or is it a circle. It should just draw it, right? How do you draw it? It's basically using a method called draw square or draw circle or whatever, but the draw shape should not worry about checking what instance it is. Is it a square instance, a circle instance, rectangle instance? Because if you start doing this kind of logic in your methods, then when a new shape comes up, you have to keep changing your code. Instead, you should write your draw shape in such a manner that you don't have to change the code. The child classes which is actually drawing the shape should handle it, not the class or the method basically who is drawing the shape, right? So understand this concept. It's saying that the function that is using pointers to the base classes must be able to do the job without even referring what are its child, because if you keep referring to your child, then your function is never complete, and whenever there's a change, your function has to change. So you should not change your function. It should be open for extension and closed for modification. Liskov substitution principle: when you have a base class passed as a reference, it should not worry about its child classes. Okay, so that's the principle about Liskov substitution principle, and I'll see you in the next one. So let's look at another principle called as interface segregation principle. Okay, this principle talks about make fine-grained interfaces that are client specific. So this is about how do you define your interfaces. And if you understand the interface concept, when you define an interface, and interface definition basically have methods. Let's say you have defined 3 methods in it. So now you are saying any class who is implementing that interface has to implement these 3 methods. Okay, and imagine a case wherein one of the class says, hey, I don't have any logic related to this method. Then that basically is a problem, right? You should define your interface very fine-grained, means very specific. Very specific interfaces should be defined so that when a class implements that interface, it should say, yeah, it's look like I have to implement all this interface, and it should make sense. There should not be a case wherein you say, oh, this method actually not related to me. So that's the principle all about. Let's look at the details of it. Okay, separate your interface method to a very specific definitions. That's what the interface segregation principle means. You have to segregate your interfaces. If required, if there are methods that doesn't really fit into that interface, you have to segregate your interface. Your interface should be fine-grained interface, means it should be very specific to that specific implemented class. When a class implement this, it is very related to that class who is implementing it. Okay, so that's why it has to be very specific definition. Okay, too many methods in one interface will force classes to implement them even it is not related. Then it's not a very good practice. Okay, you have to define your interface in such a manner when a class implements it, it finds out that all these methods actually make sense and I have to implement them. I should not find a situation saying that this interface have other methods, too many methods, and it is forcing my class to really implement them. And most of the cases, if it's not related, what you're going to do, you're going to implement it and you're going to keep it empty. Okay, that's a very wrong design. So keep the interface thin and specific to that classes it implements it. That's the principle is all about. You have to remember this principle when you define your interfaces, and whatever methods you're defining into that interfaces, it has to be thin and specific and fine-grained. So that's all about this interface segregation principle. Let's look at another principle. Let's look at the last principle, that is the 5th principle. It is called as dependency inversion principle. So let's look at the definition of it. It is reusable modules should be defined in abstraction. Okay, what are reusable modules? Okay, reusable modules like, reading a file, writing a file, converting from XML to JSON, JSON to XML, very specific reusable modules. Okay, when you define such kind of modules, you should be defined in abstraction. You should not define a module hoping that it will be used by multiple classes. Okay, it should be module of its own, right? It should do one job and one responsibility. And when anybody extends it, it should not worry about other things that this module can be do or cannot be do. Okay, it should be specific to that specific use case, and also it should be defined in abstraction, means it should not depend on somebody else. Okay, so let's look at a good example for this. Okay, so when you define reusable modules like database class, read file class, convert string class, it should be written specific and generic. Okay, there should not be dependency on anything else. Okay, the same principle can also be defined in this manner. A high level classes that uses the low level classes, which is low level classes nothing but the reusable modules, must be defined in abstraction and isolation. When you define a low level classes, you should never think about high level classes. Or when you are using a low level class in the high level class, it should not be any dependency, right? It should not say, oh, because low level uses this, I have to use the other things as well. Okay, there should not be any dependency. Everything should be in abstraction and isolation. Okay, that's how you should be defining your relationship between any two classes. Okay, most importantly, the reusable modules. Take this example and understand. If you understand this example, you will understand what is this principle is all about. Let's say you have written a low level class that is nothing but a reusable module called as read file. The read file you have defined in such a way that it only accepts JSON, okay, and nothing else, okay. And read file should able to read JSON, XML or CSV and should not be limited to XML file. But when you write read file, it doesn't tell you which file, right? And if you have defined read file by just writing JSON in it or XML in it, actually it is not doing one job, it's doing multiple job, and it is dependent on what is the type of the data that you're sending to it. Instead, you should write like a read JSON file, right? Now you're ultra specific and your abstraction, right? You're saying, okay, I am only worried about JSON and this is my module, okay? And it's very specific to that dependency inversion principle to say the read JSON file basically accepts JSON file in the constructor and it's going to return an array or maybe your string out of that JSON, okay? So thinking in abstraction, okay, don't write very generic modules and then it is dependent on something else, okay? Don't say when you write a module and don't say, oh, maybe if you don't do this it won't work that way, okay? It should be very ultra specific and it should work in abstraction. There should not be any relationship between your low level classes dependent on something else, and when a high level class extends the low level classes, it should not worry about other things that low level classes are doing. It should be abstraction. That's what the whole principle is talking about. It's talking about the abstraction and isolation. When you talk about abstraction, it is independent, right? Independent of doing one job and not dependent on anybody else, okay? So that's basically a principle. So all this solid is basically a principle. It's hard to imagine what to write sometimes, what is they're talking about, but you have to think about principle as in a design, okay? This is nothing but a thinking pattern, right? You have to think in terms of these principles. One good example is one class, one responsibility is a thinking pattern. It's not a rule. It's not something you will get an error when you don't follow that pattern. It advised by an expert who has already seen the issues in software development. When they write big projects, when they don't follow a principle, they end into a chaos wherein, you know, they have a lot of dependencies and they cannot extend the project and all those things. Just to solve all those problems, this principles has been defined. So you can choose to implement this principle, and also once you understand this, you follow in your design pattern, in your writing style, it gives you the more quality of your programming style, okay? And also when you go for an interview or explain this to anybody else, you get more added benefit because you understand how to write in OOPs much better code with also some design principles in back of it, okay? Well, that's all about the solid principle, and I'll see you in the next one.